Good morning, good afternoon, good evening. We are back and better than ever. Finishing up intersecting lines and relationship between lines. And we just have this one example to do. What we have here are three lines given in parametric equations. And our first thing we have to do is show that line 2 and line 3 intersect and then find the angle between them. Well, if they intersect, then they have a point in common, and if they have a point in common, then their x coordinates are going to be equal, as are their y, as are their z. So we are going to set them equal to one another in order to find them. So we get 1 minus t is equal to 1 plus 2u, and solving for positive t, that equation, we get t is equal to negative 2u. And then for the y coordinates, we simply get t equals negative 1 minus u, setting those equal. So I have this one, I have this one, and then z, what happens? So I have 3 minus 2t is equal to 4 plus 3u. And with some algebraic manipulations, I get 3u plus 2t is equal to negative 1. Okay. Let's see. So if I solve these, let's see. I get, okay, this is my third equation. If I set t equal to t right here, this gives me negative 2u equals negative 1 minus u, and solving that I get u equals 1. Okay, and if u equals 1, then I get, if I replace u with 1 here, then t equals negative 2. Easy peasy pumpkin pie. Okay, so if I check this, if I check these values, I should get a true equation here. This is my check to make sure that they intersect. So I'm going to replace u with 1 and t with negative 2. So 3 times 1 plus 2 times negative 2. Does that equal negative 1? It certainly does. 3 minus 4 is negative 1 equals negative 1. So we have a check. So where do they intersect? Well, if I use u equals 1, I can use any one of these equations. Okay. So let's see, I'll use, or any one of these lines, I'll use line 2 here. So if when u equals 1, okay, using line 2, then, oh, that's no good because these are all used here. I'm going to use line 3, and I want to deal with 1. So 1 plus 2 times 1, so that's going to be 3. And negative 1 minus 1 is going to be negative 2. And 4 plus 3 is equal to 7. So they intersect at the point 3, negative 2, 7. Okay? And the angle between them, between 2 and 3. Well, the direction vector for line 2, I'm going to put over here, is going to be negative 1, 1, negative 2. And so that's for line 2. And then the direction vector for line 3 is going to be 2, negative 1, 3. 2, negative 1, 3. Okay, and that's for line 3. So the angle between them is going to be the arc cos of, I don't know, what do we want to call this? We'll call this vector A, and we'll call this vector B. And these are lines, so I have to do absolute value. Remember, that's the absolute value of A dot B over mag A, magnitude of A, times magnitude of B. Okay, and that's going to equal, let's see, cos negative 1 of 9 over root 84. That's a 9, okay, which is approximately equal to 10.9 degrees. Okay. All right, so that's part A. And let's see, I am going to move to another page to do part B. Okay, so this is here. I pasted twice. Okay, so now part B. Let's finish that up. Okay, show that line 1 and line 3 are skew. Okay, well, if lines are skew, we have to show two things. If lines are skew, then they do not intersect. Intersect. Okay, if they don't intersect, they could be parallel. So then they would be in the same plane, and if they're skew, they're not in the same plane. So I also have to say that, or show that they are not parallel. So two things. So let's start with not intersecting right here. We'll do that over here. They do not intersect. How are we going to show that? Well, if we try to solve for their intersection point, then we should have no solution. And we are talking about line 1, just so we don't mess up here, and line 3. Okay. So we're going to say that -1 plus 2s, this is for the x-coordinates, -1 plus 2s, if they intersect, is going to be equal to 1 plus 2u. And cleaning that up, we get 2s minus 2u is equal to 2. And then if we set their y's together, so 1 minus 2s would be equal to -1 minus u. And cleaning that up, we would get -2s plus u equals -2. And their z's would be 1 plus 4s is equal to 4 plus 3u. And if we clean that up, we get 4s minus 3u is indeed equal to 3. Okay? So if I solve these, like let's do the x's and the y's. If I get a system of equations here, 2s minus 2u equals 2, and 2s plus u equals -2. Okay, I'm going to take, let's see, oh wait a second, this is -2s. So I'm going to combine those, and I get -u equals 0, right? Okay. So then from there, if u equals 0, that means u equals 0, right? Okay. So then using substitution, I get 2s minus 0 equals 2, or s equals 1. Okay. So then I'm going to replace s and u in there in this third equation, and I would have 4 times 1 minus 3. Oh no, 4 times 0, wait a second, s is 1, sorry. 4 times 1 minus 3 times 0 for u, and I'm wondering if that's equal to 3. Well, 4 minus 0 does not equal to 3. So I get a nonsense equation, so I have shown that they do not intersect. Okay? So now all I have to do is show that they are not parallel. Okay? Well, what's the directional vector of this guy? That would be 2, -2, 4, right? And here would be, for line 3, the directional vector would be 2, -1, 3, okay? So if they're parallel, they're multiples of one another. But there's nothing that I can take, well, if I have 2, -2, 4, and I try some constant k times 2, -1, 3, you just really kind of have to do it in your head, okay? Take the x's. What would k equal in order for the 2's to be equal? Well, k would equal 1, because 1 times 2 is 2, then these would be equal. Well, if k equals 1, 1 times -1 is not -2. So there you have it. There is no possibility of them being a multiple, or they're not multiples of one another. Therefore, they are not parallel. So if you have this on your paper and this working here on your paper, you have shown that the lines are skew. That is it. I am out!